step here. Let's go ahead and start it out like we did before. 2 moles of sulfur times the molar ratio. What's the molar ratio? I get 8 moles of iron sulfide, right, for every 1 mole of sulfur, right? So let's go ahead and put that in here before we forget. 8 moles of product for every 1 mole of sulfur. Very good. Now if I go ahead and just times that there, let's go ahead and times it so it's not confusing, right? 2 times 8 is 16, divided by 1 is still 16, so I get 16 moles of iron sulfide. But that was not the question. The question was, how many grams do you get? So we need to do an extra step here. And remember, the way you convert moles to grams, mass, is by multiplying by the molar mass. You can do the calculation. I think most of you know how to figure out the molar mass of iron sulfide. Comes out to be 88 grams per mole, right? 88 grams per mole. Let's put that in here so we don't get confused. 88 grams per mole. Okay, so if we times by 88, 16 moles times 88 grams per mole is 1,408 grams. That's a lot of product, right? 2 steps, right? First step, use the mole-to-mole ratio that you've gotten in the balanced equation. Second step, convert the number of moles to grams by multiplying by the molar ratio, the molar mass. Let's try another one. Now here's an interesting one, conservation of mass. We've talked about this a lot, right? And this is good verification that what I'm doing is true. If I have balanced things correctly, and if stoichiometry is true, then we should have conservation of mass. That is, the mass of the reactants should equal the mass of the products. So in this one, I've already balanced it, right? 4 irons plus 3 oxygen molecules come together to make 2 molecules of iron oxide. Let's check out the molar masses and the weights. Now I've already done it for you here. The weight of iron is, I'll go ahead and circle this so you can all see what I'm talking about, is 55.85, and I have 4 moles of it, so that gives me 223.4 grams. Okay? The molar mass of oxygen, and most of you probably remember that one, is 32. You have 3 moles of it, so that should give you 96. And the last one here is our product, and our product, right, is iron oxide, which weighs 159.7. You have 2 moles of it up here, gives you 319.4. And I think you guys can see that if you add up your reactants here, you will see that these reactants, right, add up to 319.4. Reactants equal the same mass as products. Conservation of mass seems to work if we have a balanced equation. Well, you go ahead and try one. Check this one out. Now this is our classic equation. Every time we light up the Bunsen burner, right? Methane gas plus oxygen, combustion, right? One of our 5 reactions gives us water, carbon dioxide. It should work for this. If we have balanced equation, we should be getting conservation of mass. Let's start out like we always start, right? Let's balance this equation. 1 carbon, 1 carbon. 2 hydrogens, 4 hydrogens. Oops, that's no good. Let's go ahead and balance this guy by putting a 2 in there. Let's do the oxygens now. 2 times 1 is 2, and another 2 is 4. Oops, but we only have 2 there. So we need to have 4. And how am I doing? 1, 1, 2. I think I'm balanced. So the mole-to-mole ratios are 1 to 2 gives us 2 to 1. Fair enough. Here's my question for you. Make that a little bigger here. I don't know if you can see it. Let's choose a bigger font here. Okay. Balance this equation and convert to grams and check for conservation of mass. No problem. Let's go ahead and do it. Okay, I'm going to go ahead and write these in, but I hope that you guys remember how to do this, right? So, methane gas, right? Methane gas, CH4, is 12 plus 4. That should be 16, right? No problem. Oxygen. Now oxygen, 2 oxygen is 32, right? But remember, you have 2 of them. So this really weighs 64 grams. Water. We always remember water. That's one I told you to remember all the time. That was 18. But you have 2 of them. So that means 2 times 18 was 36 grams. And carbon dioxide, you've only got 1 molecule of it. Carbon is 12. Oxygen is 16. So you have 2 oxygens, that's 32. Plus 16 means you have 44. I think you can see that 16 plus 64 in the reactants, surprise, surprise, equals 36 plus 44 grams in the products. I'm going to put grams there so we don't forget. This is mass. Conservation of mass holds if you correctly balance an equation. Okay, let's move on. How about this equation? In this example, we're taking solid lithium, diluting it in water. We get lithium hydroxide plus hydrogen gas. First of all, is this equation balanced? Let's take a look. 1 lithium, 1 lithium. Good. Let's do the oxygen next. 1, 1. Good. Hydrogen, 2, 2. Hey, did I get lucky? I think I did. No, I didn't. I've got 3 hydrogens over here, don't I? That doesn't work out. So let's go ahead and put a 2 in here. Now I've got 2 lithiums though, right? Let's put a 2 over here. 2 lithium. How about my hydrogens? 2 times 2, 4. Oops, need a 2 over here, don't I? And oxygens. 2 times 1, 2. There we go. That looks balanced. Okay, so the mole-to-mole ratios are 2 to 2, gives us 2 to 1. Given that you have 4 moles of lithium and unlimited water, so the water's unlimited, that doesn't matter. Okay, let's cross that out. We don't care about water. The amount of product will only be determined by the amount of lithium. And we have 4 moles of lithium. How many grams of hydrogen gas, then, do I get from the lithium? Very good. So we're starting with lithium, right? Let's go ahead and write that down. We start with 4 moles of lithium. Very good. Now we're going to times it by the mole-to-mole ratio we got in this recipe. And the ratio is we get 1 mole of hydrogen gas, right? I'm going to see if I can put a subscript on this so you can really see it, right? 1 mole of hydrogen gas, and we get 1 mole of hydrogen gas from every 2 moles of lithium. See the 2 up here? So you get 1 of these from every 2 of these. Great. Let's times it. 4 times 1 is 4 divided by 2 means that I get 2 moles of hydrogen gas. Very, very good. Now let's do that trick here again on the subscript. That's great. But that was not the question. The question is, how many grams of hydrogen gas do you get? Okay, so we need to multiply this by the molar mass. What is the molar mass of hydrogen gas? Very simple. H is 1, so H2 would be 2. So it's 2 grams per mole. Multiply that out. 2 moles of hydrogen times 2 grams per mole gives us 4 grams of hydrogen gas product. It's a 2-step equation, right? This is the beginning of stoichiometry. Try another one.